Hi everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajlakshmi College of Arts and Science. In this series, we are going to discuss about the artificial personality. Here we see the how to create a model of human behavior for conversational robots. So it is the understanding emotional awareness in human-robot interaction. First, we see the introduction. For a robot to engage in meaningful conversations, it must be capable of understanding and responding to human emotions. When people interact with each other, they naturally adjust their tone, words, and responses based on how the other person is feeling. If a robot lacks this ability, its interaction will feel robotic, repetitive, and impersonal, making it difficult for user to connect with it. By implementing a simple emotional model, the robot can recognize basic emotional cues such as happiness, sadness, friendliness, or frustration. It is based on language patterns. This allows the robot to adopt its responses, making interaction feel more natural and engaging. As a result, user will have a better experience, feel understood, and be more likely to continue interacting with the robot. Next, we see the why we need the emotional modeling. So, human expect emotional understanding in conversation. In human interaction, people naturally expect others to recognize and respond to their emotions. For example, if someone is sad, they expect empathy. If they are happy, they expect a positive reaction. So a robot that does not acknowledge emotions can feel disconnected and frustrating to interact with. So it helps robot respond appropriately to user. If a robot can detect emotions, it can adjust its tone and responses to match the user feelings. For example, if a user expresses frustration, the robot can apologize and offer help rather than contributing with a standard responses. Prevents frustration due to robotic or insensitive responses. A robot without emotional intelligence may respond mechanically or inappropriately to a user mode. For example, if a user say, "I had a terrible day," and the robot replies, "That's great, this feel insensitive." So the emotion detection helps the robot avoid such mistakes and mm, such mistakes and keep aware of them. Emotionally, making them more effective in roles like virtual assistant, customer support, and companionship. By integrating emotional understanding, robots can simulate human-like conversation, making interaction more meaningful and enjoyable for the users. Next, we see the emotional model. So the model human emotions in a simple yet effective way. We use two emotional axes that represent a person's emotional state. First one is a uh, happy, sad. Another one is a friendly and distant. So these axes represent the emotional state of the user. A person who is happy may use positive words like great, exciting, or awesome. So a person who is sad might use like upset, frustrated, or bad day. So the robot will detect these words and adjust its responses accordingly. Uh, accordingly. So next one is a friendly and distant. So that this axis represents social engagement or how open the person is to conversation. So a friendly person might ask question, use polite words, or engage in long responses. Yes, the distant person may give short replies, yes, no, fine, or show disinterest. So neutral starting point and dynamic updates. At the beginning of a conversation, the robot assumes the user is neutral in the middle of the both axes. As the conversation progresses, the robot updates this model based on the words and tone the users. So by using these two simple emotional axes, the robot can track and respond appropriately to emotions, improving user experience and making interactions more engaging. Next, how to detecting emotion through language. To understand human emotion, the robot will rely only on text analysis rather than vision or facial recognition. This means the robot will determine a person's emotion state by analyzing the word they use during a conversation. Words are assigned emotional values based on sentiment. Words like happy, great, and excited indicate a positive sentiment. Words like sad, angry, and frustrated indicates a negative sentiments. The robot assigns numerical values to word to measure emotional changes over time. So, for example, if user says, "I'm really upset today," that happy score decreases. If the user gives short, cold responses, "fine, okay, whatever," the friendly score decreases. So, by analyzing the text sentiment, the robot can dynamically adjust the responses to match the user's mood, making conversation feel more natural and engaging. Next, we see the adjusting responses based on the emotions. So it is if a user appears sad, the robot should offer encouragement. So if user is distant, the robot should ask open-ended questions. If the user is frustrated, is detected, the robot should clarify and adapt. So these are the so these adaptive approaches make the robot more human-like and improves the overall user experiences. Next, see the handling frustrations. So when a user expresses frustration, it usually means the robot is not responding in the way they expect. If the robot does not acknowledge this frustration, the conversation can become even more frustrating for the user. To prevent this, the robot should follow these steps. The robot should acknowledge the frustration. If the user says, you are not understanding me, or "that's not what I mean," the robot should recognize the frustration and respond appropriately. So acknowledge shows the users that the robot is actively listening and willing to improve. The robot should attempt to clarify. Instead of continuing with the same approach, the robot should ask for the clarification to better understand what the user means. For example, responses, "I'm sorry if I misunderstood. Could you rephrase that? I want to make sure I get it right." This responses does two things: apologies for the misunderstanding to show empathy, encourage the user to clarify the request to improve communication. So adaptive learning can improve future interactions. So we come to the end of the section. Conclusion: a simple emotional model improves robot-human interaction. By integrating a basic emotional framework, the robot can recognize how the user is feeling and respond in a more natural way. So the prevents robotic mechanical interaction and make the conversation feel more human-like and engaging. I hope you enjoy this section. Thank you.